I'm going to talk you guys through a little bit about what we're going to do for this speed of a cylinder. What that's talking about is, let me just draw it. If you have if we have a cylinder here, so let's say this is a cylinder where you can add fluid to one side and the cylinder will extend or contract. So as you add fluid into this side, so as we add the hydraulic fluid into this side, the fluid will come out of that side. And there will be, like, it's not just that it goes through the wall, there'll be like a little connector. So there's actually, I guess let's just draw it. There's actually like a little nozzle here and a nozzle here, and you'll have the actual hydraulic wires, or tubing I guess you would call it, connecting there and coming back out there. So as the hydraulic fluid goes into this side, so as the hydraulic fluid goes through this tube on into here, hydraulic fluid will leave from this side, so the hydraulic fluid will come out of this side. And depending on what pressure you're pushing into here, the rod will extend forward in this case, and the speed that it extends depends on the pressure and some other factors. So it's the pressure that's going in there and what's the area of this thing. And the reverse, so that would be called the extension speed, would be when you put fluid in here at a certain pressure, the rod starts moving, and what's the speed the rod moves at. The retraction speed is what happens whenever you put fluid in this tube. So now you're putting more pressure on this side, which is going to make the whole rod pull back inwards, and it's going to push fluid back out through that tubing. That would be called the retraction speed. And again, what pressure you're pushing into this side of the that'll create pressure, which will push on the area here, and that'll make the whole rod pull backwards. That'll be the retraction speed. So we have these two equations for rod extension speed and rod retraction speed. What I want you to do is in Google Sheets, I want you to set up a quick little calculator. I'm going to kind of write out a little bit of the beginning framework for you and then tell you all what I want you to do to finish up. This should be really like a little 10-minute thing that we'll do, and then go to the bottom of the module and turn it in down there at the bottom of the module. So we're going to open up Google Sheets, and we'll say, okay, what does this thing depend on? Well, the piston area depends on the piston radius, and the, however you say that, annulus area, that is the that's the piston area minus the rod area. So it's in that picture we drew. It's on this side. You don't get the full area. The fluid is only able to press here and here because the rod area is outside. It's way up here. It's outside of the cylinder. So instead of being able to push on the whole side like on this side, you can push just on the full rod area. You can push all along that. On this side, it's the piston area, and then you have to remove the rod area. So we're using the circle equations, pi r squared. So the piston area depends on the piston radius, and the annulus area depends on the piston radius squared minus the rod radius squared. And then these equations also depend on Q, which is the flow rate. So in our spreadsheet, we're going to say, all right, we probably want the piston radius. So we'll say piston radius, that'll be in inches. And we want to know what's the rod radius. That'll also be in inches. And then on these, if you double click kind of between the two regions, it'll resize the cells to be the correct, however big the word is here. So we need piston radius and rod radius. Those are required. That'll get us these, that'll eventually turn into what these areas are. We need the flow rate, so let's write out flow rate. That's in gallons per minute. We'll put GPM. So I'm putting the units on what I'm doing here in parentheses. Oh no, this one's not. There we go. Okay. We'd like the piston area, and we'd like the, however you say that, analysis area. So I'm going to write down piston area. Piston area will be in inches squared. I guess we should put those in parentheses like the rest of the units I've, well, let's just delete everything. Fantastic. All right, well, piston area. That'll be inches squared. And then however we spell that other one, I probably should have looked at how to pronounce this before I shot this video, but we got whatever that, okay, that's a different font, that's gonna bother me. Let me check for spelling in a second. Okay, so we got that. Okay, then we got the rod extension speed, inches per minute, rod retraction speed in inches per minute. So here we'll put down rod extension speed, and we'll say IN divided by MIN, and then we will check what's the rod retraction speed also. Copy that, should be able to paste that, and rod retraction speed. I need a space. Okay, I'm gonna put, what do we call it? Nice border around that, I guess. So all I want you all to do is, this should be set up where you can enter the piston radius in inches, you can enter the rod radius in inches, you enter the flow rate in gallons per minute, whatever number you want. And I want you to go through and type in the equations for these. So like, just to get you all started, let's do the piston area together, and then I'll have you fill in the rest of these, and then you'll say, save your file, then download it, and upload the file to the module at the end of this week's module. So piston area is pi times the piston radius squared. So piston area, I'll press equals. I need pi. In Google Sheets, that's capital P-I, open parenthesis, close parenthesis. And it's times, I just need the piston radius squared. Let me make sure. Piston radius squared. Okay, so times piston radius, which is cell, right here I've picked this 3. So it's that squared. And now as I change the number here, the piston area updates as I type different numbers in there. So eventually we'll have a nice little calculator that can do the rod extension and rod retraction speed. All you have to do is you just have to type in what's this, and you guys will use these equations here. Like this right here will get you the analysis area, and then once you have those two, you can use this equation here. It's 231 times the flow rate divided by the area of the piston, and on this one it's 231 times the flow rate divided by the analysis area, and that'll generate the rest of these. And then just save your file, download it, and upload it to the end of this week's module. So this shouldn't be too bad. And the user just enters the two values here of the piston radius and the rod radius and the flow rate. So I guess actually they enter 3 things. You need the flow rate. This is all user enter data. So they put those 3 things in there, and then your equations will generate all the rest. So we will stop there, and that's basically what I want you to do for that one. Shouldn't take too long.